Okay, in this example we're going to revolve the region y equals x squared bounded by y equals x squared, y equals 0, and x equals 2, which is this region right in here. I'd like to revolve this case, in this case, around the line y equals -1. So I'm going to go around this axis here. Notice that because the rectangle does not touch the axis of revolution, you're going to use the shell method. Shell method is pi integral big radius squared minus little radius squared. So I need to determine what these are. You always go in the horizontal direction, x, and in the vertical direction, this length here is y. So the height of the rectangle here is y. Now this length is 1. From y equals -1 to the x-axis is 1. So your big radius goes from the axis of revolution to the furthest point on the rectangle. So if I was to go from my axis of revolution to the furthest point on the rectangle, that's your big radius. Notice this length's y, this length here is 1. So your big radius is y plus 1. Y in this case is x squared, so it's going to be your big radius is x squared plus 1. So I'll fill in for my big radius, x squared plus 1. Minus your little radius. Your little radius goes from the axis of revolution to the closest point on the rectangle. So that's your little radius. No matter where your rectangle slides within the shaded region, this little radius, I think, is always going to be a 1. And notice from where to where on the x-axis do we integrate? Where is this bounded on the x-axis? From 0 to 2. So I'm going to integrate this from 0 to 2. Again, this is the setup to find the volume of this solid of revolution. So when I integrate this, or actually before I integrate it, I'm going to clean this up. This quantity is squared, so to square the first, twice the product in the middle, and square the last. 1 squared is 1. Minus over here, your small radius squared is 1 squared, which would be -1. I forgot the square on the setup. 1 and a -1 will add to 0. So I'm really integrating x to the 4th plus 2x squared. When I integrate this, I get x to the 5 over 5. You raise it to the 1 higher, divide by the 1 higher. 2x to the 3 over 3. Again, raising to the 1 higher, dividing by the 1 higher. And I'm going from bounds of 0 to 2. Fundamental theorem of calculus states I plug in my upper bound first. 2 to the 5th is 32. And I'll put a 2 into here. 2 to the 3rd is 8 times 2 is 16. That's if I plug in the upper bound. You always do upper minus lower. Now if I put in a lower bound of 0, both of these terms yield zeros. So a common denominator between 5 and 3 would be 15. You can always get a common denominator by multiplying the two. So if I do 32 fifths times 3 over 3, 32 times 3 should be 96. And 5 times 3 is 15. To make this into 15ths, I think I need a 5 over 5. 5 times 16 should be 80. So that makes this volume 176 pi over 15. Now this is an example of the shell method. Again, you use the shell method when your sample rectangle does not touch the axis of revolution. I hope this helps. Good luck.